welcome back, Fries.
Mango.
Are you excited?
I'm so excited!
Yeah. First step is, Fries, what's your favorite color theme?
Red or purple?
Red or purple?
Oh, you can change color theme.
Yeah. You know I used to use that color mode.
I do not know, actually.
And yes, people watching at home, this is a very important part of the tutorial. We're not cutting this out. How's that for you?
Pretty nice.
So we're going to make a file, and we're going to draw a triangle.
Two-step. How to draw a triangle? Make a file. Draw
That's
a
right.
triangle.
We're going to do the triangle first, so maybe we'll think about how to make a file later. There are sort of two things happening here. One thing is we need to get a window
All right.
open on the screen. Very, very important. And that's actually independent of OpenGL. So there's things called windowing libraries.
Okay.
The two most common windowing libraries are SDL, that stands for Simple Direct Media Layer, and GLFW, which stands for GL Framework or something like that. I'm going to use SDL. In Python,
Import.
Pygame.
We're using Pygame window?
That's right. So SDL is the C library, and Pygame is the Python binding to that C library.
I see.
So I'm going to take it nice and simple. First thing I'm going to do is I'm going to initialize Pygame. Initializes all.
Imported Pygame modules.
Yep. So there are different modules like image loading, sound as well.
Yep, that seems... The auto suggestion came up, so that seems
Yeah.
about right.
Cool.
I'll initialize that all Pygame modules.
Yeah. The next thing I'm going to do is I'm going to make the screen surface. So I'm going to make the window that displays on the screen.
All right.
What I'll do is I'll just go Pygame display set mode. And what this does is it takes in basically the size of the screen.
Size, flags, display, vsync. I guess the size is the most important one.
Yes, the size is the most important.
By default, that's 0.
Yeah, I'm just gonna go 800 by 600.
You wouldn't want a zero size.
No, I don't even know what that would look like.
Point.
Maybe it'd be full screen actually. I don't know. I think it just
You want to try
chooses. Yeah, let's try it. Let me go. I'll just super quickly. I'll talk about this a little bit later.
You know, of the course assignments, I did make a game
TK
that is
Inter.
TK Inter,
Yeah.
which is super outdated. No one
Yeah.
uses that anymore.
Oh yeah, it's full screen. Look, it's full
full screen.
How
Where
do we-
is
how do
the
we
exit? Wait,
This is
where
what I
is
was
it?
worried about. Okay, so that's what happens. If
Okay.
you don't give it a size, it just goes full screen. Okay, so let's go 800 by 600, and now we'll actually have a proper window. And if we run it,
I guess sometimes having a full screen, like a game that's full screen, it's nice as well.
I mean,
But-
most of the time, it's what we want.
So we have a window,
And now if we hit close,
something to draw on.
okay, so let's talk about events. What I'll do is I'll just print the event, just to show like what
Yeah.
an event is.
Try using print statements.
Try using print statements. You've done computer system stuff.
Yep.
You know, like the difference between polling and interrupts?
Yes.
Yeah. So Pygame is working with polling, and that's what this event get is doing. So if we don't handle any of these events sort of build up in a queue, and it just stays there. But this event get will sort of flush out the queue every time. So we can see that we've got this,
If we close it,
and we've got a whole lot of these events here.
that is
That is quit.
that is quit. So why isn't it quitting? Can I try?
Yeah.
I think we break the for loop instead of breaking the.
Yeah. Yeah.
Well, not flag.
It's just the not.
Oh, forgot.
Yes.
I coded in C for a while and then just. All right. Did I?
Right, because you've sort of said it. Okay,
Okay, that is.
so you're on the right track, but what's happening here is we have this event representation, and the first argument there is always the event type. So we see it has an integer code and also a string representation. So
Oh, so it's not event equals.
Yeah, I think it's actually event type.
Yay!
Yes.
That worked.
Very cool. Very cool. Let me show you another way we can do this. If event type matches the key down event and event key is pygame escape.
Is that an argument? No escape. K_escape.
This is the problem with not having like proper code completion, but that is the benefit of not using Microsoft. Cool. So we have this like key down, and then we have the key, which is the thing that would match with key escape. So if we hit escape,
We can quit.
next part is let's fill the screen with a color. So what's your favorite color?
To be honest, I have no idea. This is like part of me that I couldn't figure out.
Okay, well that might be a bit of a philosophical question for this.
It's philosophical.
I mean, okay, here's how we can represent colors in Pygame, just as a tuple of integers between 0.
And they're in base 10.
Yeah.
Can you write OX?
Yeah, you can do that. You can go like OXFF if you want. It's
Sure, yeah.
totally fine.
Just remembering if Python does have that hexadecimal representation. But
So here we set a mode, and that actually returned an object. It's a Pygame service. So what I can do is I can save that in a variable.
okay, and then we can change the attribute of it.
That's right. So we can say screen fill with that color.
So we're filling it every single time. So redrawing the entire screen with filling the color.
Yes.
Okay.
Yes. Now, if we run this, it's not quite going to do that. It's black. The reason for that is that we've got, actually, I'll make this more explicit by putting in a flag. For my flag, I'll go pygame double buff. And we've got a double buffered system. And what that means is we've got one image which is there. That's the thing that we can see. We've got a second image which is the back buffer. And that's the image which is being rendered to. And so the purpose of this is it's really bad to render to the thing which is being displayed to the viewer.
I have seen that.
Yeah.
The flashing screen.
Like it's glitching, it glitches out.
Yeah.
So what you can do is we can do all the work on the back buffer and then flip.
Flip as in now we're up. Once we flip, we're modifying.
Yeah, so some systems will physically like move those images, like copy from one to the other to swap them around. Some of them will just have like an array of two images and just update an index to refer to the different image.
All right.
That's sort of system specific. But what we can do is we can go pygame display flip, and that will flip them around.
All right. So that's red.
Now the question is, how can we do this in OpenGL?
Okay.
So it's actually not too bad. To enable OpenGL, what I'm going to do is I'm going to put, these are bit flags, so I'm just going to put in another one, and I'll set the OpenGL flag there.
Okay.
Now here, I'm going to configure OpenGL and tell it which color to flush out the screen with every time. And that's, sorry, I should import this. I go from OpenGL.
I was wondering how you're going to.
Yeah, import everything. Okay, so there's a PyOpenGL package that you can pip install, which has all of that. So this is GL clear color. And then we just put in, it's OpenGL, GL, I think. There we go. Clear color, and we just put in floating points. So 0.50, whereas this code here is like integers between 0 to 255.
This one is one between 0 to 1.
That's right.
I mean, 128 is half of 256. That's why it's 0.5.
That's correct.
Okay. What does the last one do?
That's alpha.
Oh, okay.
Yeah.
Alpha is.
Transparency. So that's sort of a psychotic move, is to clear with some transparency. But if you wanted to, you could do that. So now instead of filling the screen, what I'm going to do is I'm going to call GL clear. And then I need to tell OpenGL, well, what do I want to clear? There are a few options. In my case, I want to clear the color buffer. And you can chain these together as well. So for instance, if you've got actual 3D stuff and you want things to appear in front of other things, you'll have what's called a depth buffer.
So you can clear the depth buffer as well.
That's right. We'll discuss that at a later point. But as you can see, we can just go clear the depth buffer just like that.
Nothing will happen if we clear depth buffer because one doesn't exist in this case, right?
Yeah, nothing will happen. Actually, a depth buffer does exist, but by default, it's not being used.
It's not used, so we don't have to worry about it.
Yeah.
That's doing the same thing?
Same thing. And we can verify that it's not a fluke by changing some properties. So if I just put some yellow in there, we should get something like a little more orangey. That's it.
It's not the red.
It's not.
You set the color to clear, and that's just the background. You don't...
That is correct. That is correct. Okay, you feel accomplished?
Accomplished, yeah.
Now let's get in. And actually, you know what? I'm not going to worry about that yet. I'm going to draw points.
Okay.
Just a single point. So what I'll do is, like I said, we're going to just go right, simple. I'm going to begin, and I'm telling OpenGL that I'm going to...
Make a point.
Yeah, make a point.
He's making a point.
So what this is doing is this is sort of setting up a drawing operation. So anything that I put between begin and end is
going to be points.
Yeah.
They're going to be read as points for OpenGL.
That's right. So what I can do is I can go GL vertex. Let me go 2 elements floating point format. There's a few different operations here. I'm just going to go 0 and 0.
Cool. And that draws 1 point.
That does draw 1 point.
Does it have color?
Can you see it?
No. Oh, it's... Sorry, my brain went to the left upper corner instead of the middle.
Well, that's why I want to draw a point, because I was going to make a point about the coordinate system. Yeah. What we can do is, I'll just make this a little bit bigger. So I'll go GL point size, and I'll just go 32 or something.
That's pixels?
That is pixels. Here we have it. This is 0, 0. So OpenGL uses what's called normalized device coordinates. And the really important thing there is normalized. So no matter what we're doing, -1 on the X will always be the leftmost side of the screen. +1 on the X will always be the rightmost. So we can sort of verify that. So we can put in like -1.
Go to the left?
Yep.
Yep. And also the half this point is cropped off because the middle of the point goes there instead of the leftmost of point.
That's right. So that's the X. Well, how do you reckon the Y works?
There's only 50% chance I get this wrong, so negative Y goes up.
Let's give it a go.
Let's see.
I'll maybe just save.
Oh
no, yeah, there we have it.
It's down.
It's down. It's down. And this is super confusing because you know the right-hand rule?
Yeah.
Yeah. So if we have our positive x-axis here and our positive y-axis here, and then we curl around our fingers to rotate from the x to the y, our thumb's coming back at us. The thing that's confusing is that then the positive z-axis is away from us. So it's not looking out. The positive z is looking back this way. When people visualize like how far things are away from them, they usually visualize that as like further away is like more depth, like positive depth.
Oh, are we talking about 3D right now?
Yeah, now we're talking about 3D. Yeah. So the problem with that is that now, like if I'm looking out in front of me, that's like a negative z value out in front of me. And that's just a completely arbitrary decision. Some graphics APIs, like DirectX from Microsoft, actually configure things so that positives depth is out in front of us. So here's a challenge for you. Can you draw a whole bunch of points? It actually doesn't matter where.
What if I do it for, let's say, 5 points, and then I can import random as well? Actually, do not remember.
Just
Random
have a go with it.
vertex to float. I hope I remember the arguments right. Ooh. Huh. Yep, that gives you a number between 0 and 1.
Yep.
And it's a bit hysterical when you have points jumping around
Yeah.
on the
it's
positive
very good.
x and y axis.
Yes.
What's
It's
the
like-
frame rate for that?
Yeah, that's a great question. Pygame has something. Let me just go clock. Is Pygame.
I reckon that you have done this a lot, given
Yes.
that you have all that on top of your tutorial windows.
Okay. So
That is glitching a lot.
it's very, very glitchy. Let's just cast that to an integer. Yeah, so it's like, it's a lot. That's my point.
Yes,
It's a lot.
it's not a lot of objects.
How do you reckon we could draw these with some different colors?
I
I'll give
hope
you.
there is like color.
Give it a go.
OpenGL as well.
Give it a go. Yeah.
Now I'm just going to do something that might hurt someone.
That's okay. And this is how I used to program.
Doing random thing.
Yeah. That's so cool. It's confetti.
It's confetti.
It's like fireworks coming from.
Celebration.
Yeah. Now, we're going to make a triangle.
Actual triangle making.
Actual triangle making.
Let's delete that part.
When I made this draw operation, I set the drawing mode. And at the moment I was telling it, hey, draw points.
Yes.
But we can also switch this over. There are other
Lines?
options. Yep, there's lines. That's
Guess that.
fine. Yep. And there's triangles.
Oh, there is already the triangle.
Yeah. So this is what I was saying. Like, there's nothing special about OpenGL. We can just get in today and do it.
Very easy.
Yeah. So let's just go GL vertex. And I'm just going to go, let's go negative 0.75. So that's the leftmost, and then the bottom.
Somewhere in the middle, or?
I'm going to go right on the bottom. So 0.75, so on the right, on the bottom, and then, oops.
Go top?
Yeah, and top center.
What will happen if you have more than 3 vertex between the triangles? Will it draw a new triangle?
That's correct.
If you have like 4 vertex instead of a multiple of 3,
If you have 4 vertices, it'll do
or 5,
It'll do nothing.
it will do nothing.
It'll do nothing.
Like complete nothing, or will it draw the first triangle?
It will draw the first triangle.
But then just ignore the rest. Cool.
Yeah, and there are other modes that you can set up for actually like reusing those positions.
A triangle.
A triangle. Yeah. Okay.
And it's colored in.
This is like a classic OpenGL exercise. Let me just sort of redo everything that we had there. Is we can make an RGB triangle. And that is a triangle where each of the corners is a different color. So we can do that.
So red.
Yep. So just
1, 0, 0. I have the urge to correct the spacing.
yeah. Me too.
0, 1, 0.
Yes.
And 0, 0, 1. Yeah.
So this is the classic OpenGL triangle.
RGB triangle. It doesn't look very pretty under the red background. It's kind of muting it out a little bit.
But there you have it. And here you can sort of see the way the rasterizer is working. So all we had to do was declare like 3 positions and
With
three.
the color of the positions, those points should be, and then they blend together.
So there you have it.
A triangle.
OpenGL.
I probably will play around with it a little bit when I get back, but not with the red background. It's it clashes with the rainbow.
When I'm tutoring people, I often ask them just like, what's your favorite color? They're like, oh, my favorite color is green. I'm like, great. Well, guess what? We're going to make the screen green. They're like, that's so cool.
Thank you very much for today.
Yeah, no worries. Cheers.
Cheers.